Hi class, good to see you today. We are doing 16-2 congruent triangles. Okay, so far we talked about just angles and triangles and their angles inside of the triangles. Now we're going to talk about two different triangles having the same measures. So now when we have two triangles that are congruent, if I have one triangle congruent to the other triangle, then what happens is this angle measure has to be the same as that angle measure, or one of the angles in the triangle, and then one of the angles here have to be congruent in measure to the other angle in the other triangle. And the same thing goes with the last angle in the triangle. This measure and this measure have to be the same. Now, because we're talking about three different angles, we like to arc them separately. One with one arc, one with two arcs, and then one angle with three arcs. And that's most helpful in determining which of the angles actually correspond to the other angle in the triangle. And that's important because all three angles must have the same measure in the triangle. And in order for them to be congruent, we have to show that they're congruent. And a lot of times that involves showing each of the angles separately or congruent to the other angle. Now, another thing that triangles have that is important in congruent triangles is that sides are congruent in measure. So if I have this side equal in measure to this side, then I have corresponding sides of the triangle that are congruent. And then again, on this side, we have a second side. We're going to mark it with two arcs just to distinguish it from the measure of the first triangle. And then we have a third triangle here, or a third side that will be congruent to the third side in the other triangle. So all of these parts are going to be corresponding parts, and they're all congruent. There will be 6 congruent corresponding parts. 3 angles, 3 sides. And that's most important to understand about triangles, is that they do indeed have 6 corresponding parts that will be congruent. All right, so in order for them to be congruent, and I made this little congruent mark between the two triangles, then with those congruent triangles, they must have 3 congruent sides that are corresponding sides, congruent to each other, and 3 angles that are congruent to each other. And these are used all throughout our world. You see them in bridges. You're going to see a lot of times, if you look at the structure of the bridge, you'll see little triangles that are congruent that help with the structure of the bridge. And in order to make those triangles congruent, then they have to use math. And math a lot of times is what you're learning is your basics in geometry. And that is that all 4 of these triangles need to be constructed so that each of the sides have corresponding parts. They're all congruent to each other, and each of the angles are all congruent to each other. And that's pretty cool. They find that the triangles and congruent triangles are very, very useful in building, and in other ways too, but mostly in building. So congruent triangles are triangles with the same angle measures and same side measures. All right, 3 sets of each for a total of 6. That means that all corresponding parts, right, angles and sides, maybe we should put 3 angles and 3 sides, are congruent. All right, and if that occurs, then we have congruent triangles. Now, another thing that we have is a congruency statement. Congruency statements are very important because their order is very specific in a congruency statement. All right, so if you see this right here, this triangle ABC is congruent to triangle DEF. When we see that congruency statement right there, what we know from that is which angles are congruent or corresponding to each other, which sides are congruent or corresponding with each other. So if I see an A here and the D's in the same position, first position, then A is indeed congruent to D. And then the second angle B is congruent to the second angle E, and the third angle C is congruent to the third angle F. So if you look over here at these corresponding, at the congruent triangles, you see A and D have one arc showing that those are congruent. I'm going to maybe zoom in a little bit more so you can see these arcs more prominently. So A and D have one angle. They're congruent. E and B have 2 marks on their arcs, and they're congruent. And then C and F have 3 arcs, so they're congruent. And then you'll note that, again, A and D are first in first position, B and E are second, and C and F are third. And we can guarantee that. And sometimes you might even have to write a congruency statement in that way. We can guarantee that the angles are indeed matched up, that are corresponding angles. Same as AB is congruent to ED. So you see AB and DE. First position, if I were to mark a little arc or a little mark above them, segment AB, all right, is first and second position, and it's going to be congruent to the same order, D, then E, of the second angle. All right, or the second triangle. And then same with BC. So if I look at BC here, second and third, I'm guaranteed that BC is congruent to EF. All right, so if I look at B to C, that's 2 arcs to 3 arcs, then that's going to be congruent to EF, E to F, 2 to 3 arcs. All right, and the same with the last one. The last one is AC, first and third position in the congruency statement, and it's going to be congruent to DF, first and third position of the second triangle. So those 3 sides are going to be definitely congruent in the triangles. And I didn't write the angles, but I might. So angle A must be congruent to angle D, first and first position. Angle B must be congruent to angle E, second and second position. And then angle C must be congruent to angle F. And in that way, we know that for sure, because of the congruency statement, that these are the angles that are corresponding and therefore congruent, and these are the sides that are corresponding and therefore congruent. Okay? And now, we also see something called a CPCTC. What is that? What that says is if our new 2 triangles are indeed congruent, such as the 2 pictured above here, those are congruent, then that means that all and every single one of those 6 corresponding parts in the triangle are congruent. Corresponding parts of congruent triangles are congruent. And we know that to be sure. So if we do know indeed that 2 triangles are congruent, then we know that every pair, each and every 6 of the pairs of corresponding parts, that are also congruent. Very, very important. All right, CPCTC, we're going to see that again. We're going to use it a lot in proofs later on in this unit. So it's going to be very, very important. A lot of times, just as a little heads up, we know that 2 of the C's stand for congruent. And that's what most people look at this and say, oh, congruent, congruent, congruent. But it doesn't start with congruent. It starts with corresponding parts, and which also starts with the C. So note that it's corresponding parts of congruent triangles are congruent. Okay? So as an example of what we would do with these parts we are going to list all the congruent angles and sides for the triangle. Triangle JKL is congruent to triangle PQR. All right? So our angles, I know for sure, we are guaranteed will be lined up in the same order as their congruent corresponding angle. So we would say angle J is congruent to angle P, angle K is congruent to angle Q, and angle L is congruent to angle R. So it has to be that way because that's the order that we're given in our congruency statement. And then sides are going to be JK is congruent to PQ. All right, and then KL is congruent to QR. So I've done the first 2 and the last 2, and then we do first and last. So JL is congruent to PR, side PR. And we know that for sure because of that congruency statement. All right, okay. Next up, we're going to do example 2. And example 2 pictures 2 triangles, and we are to complete each of the following statements. Now you can do this one of 2 ways. You can take your congruency statement and mark these up much like you see these marked up with the arcs and the dashes. Or you can look at the position of each of these and make sure that you just give the corresponding in the position. So I'm going to kind of do both. My suggestion is, in most cases, just to go ahead and use the congruency statement. It's much less confusing because, as you see here, a lot of times they will change the orientation of the triangle. So they'll flip it, they'll rotate it, they'll do things to it to make it a little confusing. So you see K here, and then you have to look at the triangle parts and the congruency statement. I know K is congruent to A. So K is congruent to A, and they're not in the same position. K is at the top, but A is at the bottom. So those two are congruent. All right, and then P, the second letter, the second vertex is congruent to Y. So you find P and you mark it twice and Y marked twice. And then M and C are the third position. So M will get a 3 and C will get a 3. So you can see that the angles are not just slid across. They've been flipped, rotated, and whatnot to be a little bit more confusing. But I like to do KP is congruent to AY. So I have to mark those. And then PM, it's right here. And it goes from the second 2 arcs to 3 arcs is congruent to YC, 2 to 3, 2 arcs to 3 arcs. And then lastly, KM, so K to M, is congruent to AC. AC. All right, so those orders really do matter. And you can even arc the blues twice, the pinks, or arc the blues once, the pinks twice, and the oranges 3 times. And that's your markings. And you can reference over here if you want. If you see KM, so it goes 1 arc to 3 arcs, it's going to be congruent to AC, 1 arc to 3 arcs. So you would write AC there. Or you can look up here and see KM is first and last position and make it congruent to AC, first and last position. So those are 2 ways to note. All right, so CY over here, C goes from 3 to 2, CY. So if we go 3 to 2, it would be MP. Or if we look up here, we'd say CY is, and then MP are in the same order, in the same position in the congruency statement. All right, PK. So we have P to K, so 2 to 1 arc. So 2 to 1 arc would be YA. Or K to P, A to Y. Woo! Did I do that backwards? P to K, Y to A. All right. And then D is angle Y. So we were doing sides, now we're doing angles. And so when we have angle Y, it'll be congruent to angle P. They're both with 2 arcs, or Y and P. Angle K has 1 arc, and so does A, so it would be angle A angle K would be congruent to. And then angle ACY, so ACY, so 1, 3, 2 will be congruent to KMP. And we do an angle KMP. All right, and again, if we looked at over here, we have ACY, so first, third, second. We'd have to go first, third, second, KMP on our congruency statement. All right, now we're doing triangles. So we're 2 different statements, congruency statements, which will be true congruency statements as long as we line up the angles correctly. And there'll be 2 different ways to write that one. So triangle MPK, so it went from 3 to 2 to 1, is going to be congruent to triangle 3, 2, 1, CYA. Triangle, make that first, CYA. It's important to write the triangle because then it distinguishes that we're talking about the triangle and not just an angle. If we want the angle, we write an angle in front of it. And if we want a triangle, we write a triangle in front of it. And then YAC, so we have Y to A to C, so it's 2 to 1 to 3. So we need to go 2, 1, 3. So PKM, triangle PKM. All right, and that's as much as I'm going to do right now because our time's up. And I will do part 2 and part 3 if necessary. Thank you. So stay tuned, watch this one, and part 2 is next.